Hi everyone, this is Lakshman again. Welcome to online tutorial program. Today's program is carbon nanotubes. This is basically made placing in mind that students of BSc who are going to face the cluster examinations. For them it is exclusively made. Carbon nanotubes. We know well about carbon nanotubes, which are nothing but finest and well graded allotropic forms of carbon. These carbon nanotubes, there are two types of carbon nanotubes like single walled and multi walled, based on the method of manufacturing, that means fabrication, and the method of structural features. Based on these carbon nanotubes are classified into two types. Let us discuss what are the peculiar properties that made these carbon nanotubes as a special type of carbon allotropic forms in the industry, and what are the special areas where carbon nanotubes finds applications, and what are the special properties, how these carbon nanotubes can be fabricated using different kinds of methods. All we are going to discuss here. Carbon nanotubes are long, thin cylinders of carbon, and these are formed of macromolecules. The shape, if you see the shape of the carbon nanotubes and the size of the carbon nanotubes, all these are in the dimensions of nano range. That means of the order of up to 100 nanometers of maybe the sizes and the diameters are of also 2 to 3 nanometers like this. Let us see. Carbon nanotubes, long, thin cylinders of carbon, are the large macromolecules that are unique for their size, shape, and remarkable physical properties. They can be thought of as a sheet of graphite rolled into a cylinder. Carbon nanotubes are just one atom thick with a diameter of only 1 or 2 nanometers. Carbon nanotubes have a very broad range of electronic properties, thermal properties, structural properties, and based on these properties, different kinds of nanotubes, as we said in the, earlierly, like single walled or multi walled carbon nanotubes are classified. See, as we said that a thin sheet of graphite which is rolled in the form of a tube leads to the formation of carbon nanotube. If only one sheet is rolled in the form of a sheet, we have a single walled carbon nanotube, whereas different sheets of different thickness, different radii, and different composition are rolled in the form of a single tube, then it may be a multi-walled carbon nanotube. Now let us see. Here we are seeing that this is the single walled carbon nanotube. As the single walled, here see only one wall of the carbon graphite sheet is observed. But coming to the next case, here this yellow one, blue one, and white one. Here 3 layers of graphite sheet are rolled out in the form of a tube, which leads to the formation of a multi-walled carbon nanotube. What are the basic and key properties to say in the form of bullet configuration? Carbon nanotubes are an example of true nanotechnology. They are less than 100 nanometers in diameter and can be as thin as 1 or 2 nanometer in thickness. They open an incredible range of applications in materials, science, electronics, chemical processing, energy management, and many other fields. Extraordinarily, electrical conductivity, heat conductivity and mechanical properties of carbon nanotubes makes it used widely in the fields of electricity, electronics, thermodynamic industry and mechanical industries. They are probably the best electron field emitter known, largely due to their high length to diameter ratios. As pure carbon polymers, they can be manipulated using the well-known and the tremendously rich chemistry of that element. As see that these carbon nanotubes, because of having these, that means these materials basically, whether or not it is the carbon nanotube, first of all, nanomaterials which are having special properties in the fields of electricity, electronics, thermal properties, mechanical properties, or even the chemical properties. Because of those specialty in their all these fields of properties, these are much widely used in those areas and performing better performance. See, where these carbon nanotubes can find applications in the fields of emitters, that means as emission of such as energy, conductive or reinforced plastics, molecular electronics, the CNTs based non-volatile RAMs, CNT based transistors, energy storage devices, CNT based fibers and fabrics, CNT based ceramics, biomedical applications, etc. are the key positions where these nanotubes, carbon nanotubes finds applications. Now see that in a detail, the carbon nanotubes are having possessing these kind of properties. The structure of a carbon nanotube is formed by a layer of carbon atoms that are bonded together in a hexagonal mesh. As we said that carbon nanotubes are basically formed by means of rolling of the thin sheets of graphite. As a graphite sheet is having, that means the structure of graphite is hexagonal carbon atom structure, the basic allotropic form of carbon. So carbon nanotubes which are made of the rolling of graphite sheets, these are also having the hexagonal structures. This is the basic point that one have to remember. The one atom thick layer of carbon atom is called graphene, and it was wrapped in the shape of a cylinder and bonded together to form a carbon nanotubes. Now, carbon nanotubes have a single outer wall of carbon or maybe can be of multiple walls. As it is possessing a single outer wall of carbon, then it is simply said to be the single walled carbon nanotube, or if it is made of multiple walls, then it is called multiple walled carbon nanotube. See that single walled carbon nanotubes. As we said that carbon nanotubes made of single outer walls of graphite sheet, which is rolled in the form of a cylinder. This is called a single walled carbon nanotube. Again, these single walled carbon nanotubes classified into armchair, chiral and zigzag depending on the internal structure of the graphite. These are classified as armchair structure, chiral structure and zigzag structure. See this, the design depends on the way the graphene is wrapped into a cylinder. For example, imagine rolling a sheet of paper from its corner, which can be considered as one design, and a different design can be formed by rolling the paper from its edge. In the similar way, single walled nanotube structure is represented by a pair of indices which are called chiral vectors. See, these three structures, that means zigzag structure, armchair structure and chiral structures, we can see like this. Now see, single walled carbon nanotubes also having, see that the structural design has a direct effect on the nanotubes electrical properties. As we said that these are having a special properties of special electrical properties. The way these special properties comes from means that this is because of the internal structure of the nanotube, where the chiral vector is a multiple of 3, then the nanotube is described as a metallic, whereas we know that all metals are good conductors of electricity, so that these carbon nanotubes are also behaving as a good conductors. Otherwise the carbon nanotube is a semiconductor, or otherwise it is a insulator. That is. Now coming to the case of multi-walled carbon nanotube. There are two models of multi-walled carbon nanotubes. As they are, these two models are nothing but the method of these are classified by based on method of synthesis. In the Russian doll model, that means first model, which is called a Russian doll model, a carbon nanotube contains another nanotube inside it. In the palm sheet model, the single graphene sheet is rolled around itself multiple times, resembling a rolled up scroll of paper. As we see that in the first case, first of all, a carbon nanotube is made, and this nanotube is surrounded by another nanotube, and that nanotube is surrounded by another nanotube, and this process is continued. Then such a model is called Russian doll model. And the other model in which a single sheet of graphite is rolled out to form multiple rollings. That means in the first case, different sheets of different dimensions and different properties may be rolled out, but in the second case, only a particular case of the sheet which is rolled in the rolled to form a multiple walled carbon nanotube. The multi-walled carbon nanotubes have similar properties to the single-walled carbon nanotubes, but as we seen that outer walls of multi-walled nanotubes, these outer walls just protects the inner walls. Of course, the multi-walls carbon nanotubes are having better performance in the properties when compared to the single-walled carbon nanotubes, depending on the type of the application and depending on the area of application. These properties may vary. Now see, as we said that these are having a special that means peculiar properties of mechanical. That means mechanical constants like stiffness constant or Young's modulus, or all these properties, they exhibit in a different way. As we see that the strength of the carbon nanotubes is also found to be very high. From where this higher strengths of carbon nanotubes are arising? Carbon nanotubes, let us see. Carbon nanotubes have a higher tensile strength than steel and carbon. Their strength comes from the sp3 bonds between the individual carbon atoms. Under high pressure, individual nanotubes can bond together, trading some sp2 bonds for sp3 bonds. This gives the possibility of producing long nanotube wires. Carbon nanotubes are not only strong, they are also elastic. The nanotube's strength can be weakened by defects in the structure of the nanotube. Of course, let us come to the explanation part of this one. Since as we said in the earlier, carbon nanotubes are rolled out by the graphite sheets. As we know that in graphite, the basic bonding structure, that means basic bonding structure between s and p orbitals is sp2 hybrid or hybridization. As we see the sp2 hybridization, there are, compared to diamond where we can find sp3 hybridization, here only we are having sp2 hybridization. Not only that, as we said that in the basic properties of carbon nanotubes, these are the perfect crystalline materials. That means the structure of these carbon nanotubes is very perfect. Because of all these properties, they are possessing higher strengths and higher elastic modulus like Young's modulus or stiffness constants, etc. and etc. But the strength of the carbon nanotube is weakened by the presence of defects, which is also a basic property, and this may sometimes helps the nanotubes for some special applications. Now see that the electrical properties. The structure of CNT determines how the conductive it is. When the structure of carbon atoms in a carbon nanotube minimizes the collisions between the conduction electrons and the atoms, a carbon nanotube is highly conductive. This is quite natural and similar to the conduction in the metals. As we see that whenever there is a collision, internal collision between atoms or electrons, etc. and etc., this leads to the thermal agitation, which is a opposition for the conduction of electricity through that metal. As we see that here also in the carbon nanotube, if there are much lesser collisions between carbon atoms and the conduction electrons, then this results in higher conductivity. The strong bonds between the carbon atoms did not allow the electrons to collide with the atoms, so that carbon nanotubes can exhibit higher conductivities as these carbon nanotubes are behaving like metals. Now see that the strong bonds between the carbon atoms also allow carbon nanotubes to withstand higher electric currents than metals like copper, etc. Single walled carbon nanotubes can route electrical signals at speeds up to 10 gigahertz of speed ratings. And now see the thermal properties. The CNTs are very good thermal conductors when compared to copper wires. The thermal conductivity of CNT is 15 times more than the copper or etc. Now let us coming to the very basic applications of these carbon nanotubes, which are called as potential uses. There are many potential applications for carbon nanotubes, from waterproof and tear resistance of cloth fabrics, concrete and steel like applications based on its property. That means in some situations we are basically considering electrical properties, in some other situations we are basically considering thermal properties, and some other situations we are basically conducting mechanical properties. Based on mechanical properties, the carbon nanotubes are used for some other some application. Based on electrical properties, the carbon nanotubes are used for some other applications like this. Anyhow, we just see some of the major applications of these carbon nanotubes. First one, nano-electronics. The single-walled nanotubes being highly conductive used widely in the domain of nano-electronics. Single-walled nanotube ropes are the most conductive carbon fibers known so far. Alternative configurations of carbon nanotubes can result in the resultant material being semi-conductive like silicon. Conductivity in nanotubes is based on the degree of chirality. The degree of twist and size of the diameter is the actual nanotube. That means, see that as the chirality increases, the conductivity decreases. Of course, in single-walled carbon nanotubes, because the bonds are very strong and only a single type of carbon atoms are presenting, here the SWNTs behaves like metals, which are good conductors of electricity. So they are being highly conductive. They are used in the nano-electronic domains. Not only that, these single-walled nanotubes, which can be made in the form of nanofibers, are used for long-distance electronic communications also. Next, interconnect. With high conductivity and small dimensions, carbon nanotubes can be used in IC manufacturing. Another advantage of carbon nanotubes is there is no need to embed the interconnects into trenches on the circuit board, which could make for a simpler manufacturing process. And we see that nowadays microelectronics are already gone, nano-electronics is now running. See, in the case of mobile technology, we are seeing different platforms of SoCs, which are called system on chip. That is basically depending on the processor. Suppose if we see some kind of mobiles, we are seeing that 12 nanometer platform, and some mobiles we are seeing 11 nanometer platform. Now it is running 5 nanometer platforms and 7 nanometer platforms, etc. are running. That means that as the nanometer platform, that means the dimension of the SoC. As the dimension of the SoC is reducing, automatically consumptions are reduced, thermal properties, that means thermal emissions are reduced, etc. Everything is taking place. Since nanotubes are basically highly conductive, these can be used in the manufacturing of integrated circuits in the micro to nano electronic systems. Now, nano transistors, which are also called as transistor CNTs. Transistors form the basis for the modern integrated circuits functioning as digital switches. We know well that because of the transistors, the ICs, which are nothing but the combination of different transistors in their different functioning modes, which is also called as LSI technology, large scale integration. VLSI technology, very large scale integration, etc. and etc. Of course, as we are using integration technologies based on transistors, but the integrated circuits are occupying more and more sizes. But as the time being, needs are very much, and faster technologies, faster results are required. So that we have to go for new and new technologies. Here, carbon nanotubes, which are used in the form of transistors, serves the best for the purpose of nano-electronics. See that this transistor is having two states, like saturation state and active state. So that means as like a electrical switch, which is having two states like off and on, transistor is also having off and on. But the on and off frequency of transistor is very much high, so that these transistors can be used as digital or electronic switches. Single wall nanotubes act as transistors, and these can serve the purpose of digital switching. Nanotubes based switches can operate even at cryogenic like temperatures. That means these are also temperature resistance. So in such a nano transistor, molecules can be positioned inside a carbon nanotube to affect the electronic current flowing across it, so that the molecular scare gate, in which the position of the molecule controls the flow of the electrical current by reducing the emissions, by reducing the wear and tear, by reducing the failure frequency, etc. and etc. Here, nanometer sized atoms, here we can having very much small and small, that means very small sized SOCs can be made and fabricated with the help of nanotransistors. Okay. Next, energy production and storage. So that means that these nanotubes, which are used for the purpose of storage purpose, like in the case of electrical, that means condensers, which can store the electricity. Like here also, nano materials which are used for the storages, nano batteries. Basically, see that carbon nanotube technology can be applied for a wide range of energy related applications, that they are batteries. Most portable electronic devices use a rechargeable lithium ion batteries. It is found that single walled carbon nanotubes can double the storage capacity of a battery than any conventional one. In electronic vehicles, the reduction in weight can make a significant reduction in the battery power requirements. And next, carbon nanotubes have been used in supercapacitors producing a power density of 30 kilowatts per kg. Such a supercapacitor can drastically reduce the time and it takes to recharge devices such as laptops, cell phones, etc. and etc. Ultra thin flexible batteries have been made with CNTs infused vapor. Electrolytes in human blood, sweat and urine can also help to power the battery, which may be useful in implantable medical devices. These batteries can be rolled, fold or cut without loss of efficiency. As we see in that nowadays we are having smartwatches which can detect directly by contact with the human body. They detect blood pressure, they count the heartbeat, also they measures the sugar levels also just by contacting the body. How these smartwatches or smart bands are now performing all these functions means that they the nanomaterials which are related to these functions are embedded in the SOC of the smart band, which can function as it is directed by the processor. Next, these carbon nanotubes also used in the manufacture of solar cells. These solar cells made with carbon nanotubes are showing much better performance when compared to the conventional solar cells. See that solar cells CNTs grown on iron coated silicon wafers in the form of towers can absorb more light as it reflects off the sides of the towers. Unlike typical solar cells, that have peak efficiency when the sun is at 90 degrees. These cells have two peaks at 45 degrees and operate with relatively high efficiency during the most of the day. This makes them for use in space because it eliminates the requirements of the orientation of the cells to face the sun. You see that as it is explained, conventional solar cells requires always facing of the sun. If sun is, as we know that sun is not fixed one, so that and these solar panels cannot be made to rotate like a sunflower as sun moves from east to west or west to east. So that certainly conventional solar cells are facing the sun only at some time, and these are faded off at some other times. But as in such situations, these receives less amount of solar energy or cosmic energy from the sun, and the production, that means the photo energy which is converted into electrical energy, is decreased. But when compared to these conventional solar cells, if the solar cells made of carbon nanotubes, these does not require such kind of orientation along with the sun to face it always, so that they performs much better and they produces double the efficiency which is produced by the conventional solar cells. Similarly, environmental uses. Carbon nanotubes can hold promise for cleaning up polluted environments. Nanotubes are very effective at absorbing chemicals from their surroundings and have possible applications in water fabrication and in air filters such as smokestacks, etc. and etc. See that now fabrics, that means glass made of carbon nanotubes, which doesn't require any case of washing, cleaning or even dry cleaning. In the similar way, carbon nanotechnology used glasses which are used for some vehicles, which does not require any kind of cleaning of the glasses even in the rainy time or in non-rainy time. Just they automatically cleans up their surface when they are made with nanomaterials. And how these nanomaterials can be fabricated. The fabrication technology will require the ability to target nanotubes with a high yield of specified lengths, diameters, number of walls and chirality. There are several procedures that have been developed for fabricating nanotubes, because one kind of nanotube is made from one method only. A single method does not lead to the manufacture of different kinds of all nanotubes, or all nanotubes cannot be made from a single method, and all methods cannot produce a common type of common nanotube. We have to mind that different methods are required for producing different kinds of nanotubes. Let us see some basic methods of producing nanotubes. The basic method of producing nanotubes, first one is arc discharge method. See here there is a discharge tube as shown in this figure, and here the material which is called target or substrate, which is placed into the some discharge tube, and here when passing high power to that discharge tube, automatically discharge arc is produced, by means of which these target material which is radiated and deposited on the target, so that a small layer is formed on the surface of the target, which is upon removal from the target, it leads to the single walled carbon nanotube. Now let us see the complete description of the arc discharge method. A chamber containing a graphite cathode and anode contains evaporated carbon molecules in a buffer gas such as helium. The chamber also contains some amount of metal catalyst particles such as cobalt, nickel or even iron. A DC current is passed through the chamber, which is pressurized and heated up to 4000 Kelvin. The nanotubes grow from the surface of the metallic catalyst particles. About half of the evaporated carbon solidifies on the cathode tip into a cylindrical hard deposit. The remaining carbon condenses into the chamber soot. around the walls of the cathode suit, and chamber suit yield either single walled or multi-walled carbon nanotubes. As we said that when discharge is passed, that means when a DC current is passed through the discharge tube, then discharge takes place, and after discharge the carbon atoms which gets evaporated are deposited on the target, so that which is hardened, and this target is in the form of a layer on the the deposit is in the form of a layer on the target, which is simply removed from the target and rolled out to form either the single walled or the multi-walled carbon nanotube. See, this method produces a large quantity of nanotubes, but the main disadvantage is that there is a relatively little control over the alignment of the produced nanotubes, because of which we are upgrading to the next method, that is laser ablation method. Here in this laser ablation method, let us see the synthesis arrangement. See, this is also just similar to the which is called arc deposit method. Here also a gas tube is there. Of course, into that tube we are placing one target material, and on passing a laser of suitable intensity and suitable energy, ablation takes place. That means first of all the material which is to be converted into nanotube is first of all powderized or split into very tiny particles, and these tiny particles next forms or deposits on the tip of the target, which is called seed or nucleus, which is then removed from the tip, and the wall can be, the size of the carbon nanotube which is formed can be controlled and removed. Let us see here. This is the furnace, and here let us see this black sheet like material which is called is the which is nothing but graphite sheet, that means a carbon sheet. When a powerful laser, see the red line, a powerful laser falls on this graphite sheet, then the graphite gets evaporated. That means tiny particles of carbon atoms are evaporated, and these carbon atoms moves towards the target, and they simply deposits on the tip of the target, so that these carbon atoms which forms in the form of a layer on the target, which is also called a control rod. The layers after suitable thickness, the layers can be removed from the target and rolled out to form carbon nanotubes. Let us see. A quartz tube containing a block of graphite is heated in a furnace. A flow of argon gas is maintained throughout the reaction. Because the argon is inert gas, this does not react and this does not forms any side reactions, so that it is used. A laser is used to vaporize the graphite. The carbon vaporization is carried away by the argon and condenses downstream on the cooler walls of the quartz. This condensation is a single-walled nanotube and metallic particles. Thereafter, purification methods are applied to this mixer. The formation of the condensed nanotube starts at the location where the carbon atoms begins to condense. Should set up as a curved sheet of graphene with a catalyst. As carbon atoms begin to attach and form rings, the metallic atom, it has a proper electronegativity properties. Now, the advantage of this technique includes a relatively high yield and a relatively low metallic impurities. That means by laser ablation method we can get better purified carbon nanotubes and better faster synthesization times compared to arc discharge methods. But it is also having some disadvantages that nanotubes produced from this method are not necessarily uniformly straight, but instead do contain some branching like this. And now next one is chemical vapor deposition method. See, the experimental setup for the synthesis of chemical vapor deposition method is like this. Here also there is a tube, and in that tube we are having a sample which can be evaporated and targeted to the target so that nanotubes can be obtained. Let us see. The CVD approach allows CNTs to grow on a variety of materials. This process involves the chemical breakdown of a hydrocarbon on a substrate. The main way to grow carbon nanotubes is by exciting carbon atoms that are in contact with the metallic catalyst particles. The CVD method extends this idea by embedding these metallic properties in properly aligned holes in a substrate. Essentially, tubes are drilled into substrate and implanted with the iron nanoparticles at the bottom. The carbon atom come into contact with the metal particles embedded in the holes and start to form nanotubes that are templated from the shape of the tunnel. The carbon nanotubes grow very long and very well aligned in the angle of the tunnel. See that the angle of the tunnel. The advantage of this method is that the yield is very high when compared to arc method or laser method. The alignment of the nanotubes is consistent so that we can have either the chiral methods, zigzag methods or armchair methods. The alignment of nanotubes is consistent and the size of the growth area is theoretically arbitrary. The main disadvantage is that the large sized areas tend to crack, shrink or otherwise warp. The substrates need to be dried very thoroughly to prevent against this. Now, in a bulleted form, the properties of carbon nanotubes, let us see. It is ideal conductors of electrical energy. Higher tensile strengths are having possessed by the carbon nanotubes. Extraordinary flexible and elastic properties are exhibited by carbon nanotubes. It is excellent conductors of thermal energy. Carbon nanotubes are having higher aspect ratios. Excellent electron field emitters are carbon tubes absolutely. Lower thermal expansion coefficients also possessed by carbon nanotubes. Now, the different types of carbon nanotubes individually, applications of single-walled carbon nanotubes and multi-walled carbon nanotubes. Let us see. Single-walled carbon nanotubes can find applications as described here. They are used as additives in the polymer or plastics for increased strength and electrical conductivity at the same time, as a catalyst in several chemical reactions for better controlled reactions and best results. They are used as emitters of electron field, perfect for cathode ray lighting devices, as a more efficient material for flat panel displays, as gas discharging tubes in telecom networks, for electromagnetic absorption and shielding. Single wall nanotubes are all used. These single wall nanotubes are also used ideal for energy conversions. These are as replacements for conventional lithium battery anodes for strong hydrogen more efficiently. Now see that as nanotube composites made by coating or filing, as nano probes for EFM, STM, AFM and medicinal drug administration, as nano electrodes as parts of advanced sensors for reinforcing composites and supercapacitors. Single wall nanotubes are used. Now let us see the applications where multi-wall nanotubes finds. The most use of multi-wall nanotubes are following: the use of MWCNTs, that means multi-walled carbon nanotubes in batteries can double the storage power. In solar cells, as multi-wall carbon nanotube based solar cells have 100 micrometer height towers that absorb remarkably more sunlight compared to the conventional solar cells, thus ensuring significantly higher power generations. In transistors, where the size could be remarkably decreased even further, resulting in more compact and micro version of electronics, multi-wall carbon nanotubes are used. These are also used for flat panel displays. As a global electronics brand, Samsung has already fabricated a field emission display with MWCNT strips on the cathode and phosphor coated ITO strips on the anode. In case of better energy storage, MWCNTs are more powerful electrochemical capacitors as compared to other forms of carbon. Thanks for watching this. Let us wait for the next upcoming video regarding nanotechnology.